Hello, everyone. I'm Bikash Singh. I work as a technical lead in MIQ. Today, I'll be co-presenting this talk with my co-presenter, Sneha.
Hey everyone, I'm Sneha Chokshi. I work as a data science team lead at MIQ, and together me and Vikas will be taking you through how we build an identity graph within programmatic media advertising landscape. So before we set it up, would like to basically introduce MIQ to all of you. MIQ is a leading programmatic advertising company. For more than 10 years, we have been working with different ad agencies and leading marketing brands to generate tangible business outcomes using programmatic marketing. We have been awarded Digital Drum Awards for US and also been on the top 200 track. So in today's session, we are going to cover three things. What identity graph means and how it fits into programmatic advertising, how we built it, and the third part being how it impacts our business and helps us achieve outcomes for our clients. I'll just set up some context around what programmatic advertising is and how Identity Spine helps us achieve some of our goals here. So programmatic advertising is when we use software to basically connect our advertisers to the end consumers using a piece of software. That means anything that is basically digitally connected via internet, that those are the platforms where we can serve an ad to connect with the consumers, and that can happen using programmatic landscape, that can happen in real time. So how this process works is, say a user logs on to a web page, meaning say, for example, nytimes.com. So a user types www.nytimes.com. While the page is loading, the ad slots on that particular web page loads up. So for example, on the first page itself, there are 3 ad slots. The website owner, who is the publisher, will get notified that, hey, these 3 ad slots have opened up. It will go into the ad marketing marketplace where a real-time auction happens. And just like with all the bidding and auctions, there will be multiple different campaigns through which MIQ would be sending bid to this particular ad slot. There will be thousands of other vendors like MIQ who would be trying to serve an ad on that particular web page. And through this auctioning system, the highest bid wins. The highest bid wins, and the creative of that highest bidder, ad bidder, gets served, and this entire function happens in a fraction of a second. That's the power of the tech stack that exists in programmatic industry. And while and the scale of it is huge, meaning there is almost like 40 billion plus ad spaces that are traded daily, generating various data points against each of those ad slots, and which amounts to almost like 20 TB of data that MIQ onboards on a day in, day out basis. So to understand the need of identity graph, it's essential to understand that programmatic landscape is a very, very dynamic industry, ever expanding. The basic one started with desktop, mobile, tablet. Eventually, all our TV devices got connected to internet, and that's where we started getting opportunities to show ad on TV also. Then eventually, a lot of you must have noticed that some of the billboards outside on the road are turning into digital screens. So that's another opportunity to trade and buy ad spaces in a programmatic manner. We have various audio platforms or audio devices, as well as apps, be it Spotify, be it say Google Alexa, be it the music streaming devices, which offer further opportunity to make that ad transaction in a programmatic manner. So as and when this particular media industry keeps on expanding its to more devices and more channels, uh, of course, there will be multiple challenges that creep up with it. The data that you collect from different channels will not be connected with each other. The level at which you will receive those data will not be connected with each other. A lot of these may sit in silos, and the planning of each of these channels may be done by different teams. Uh, so those functions may be isolated. And lastly, due to different regions, GDPR laws, compliance laws, or the privacy laws set by the owners of those ad spaces, the supply may be walled off. And to overcome some of these challenges, it's really essential to be able to overcome these challenges and to deliver a more connected marketing. A lot of these challenges need to be answered to lead to a better connected marketing, which means that all these diverse data sets and data points that we receive from fragmented channels and sources can be connected. For the user, we need to tell like a very continuous story. Or for the advertiser, it shouldn't be that the user is seeing ad or story one on mobile versus a completely different story from the client on a TV device. So the story continuity is an essential part of connected marketing. It is very essential for all of the teams working on different channels and planning on different channels have work towards the same business goal. Meaning if the business goal is driving users on site, then the TV and the desktop advertising need to be complementing each other and driving towards the same goal, need to ensure that they don't basically disrupt each other's activity. And once the planning is done, activation is done, the marketing budget is spent, it becomes essential to measure the impact of the marketing budget spent. And that's when we come to the fourth part of the measurement, where we use AI across the closed and open supply environments and data sources to be able to measure impact of each dollar that is spent in programmatic advertising efficiently. And to be able to do that, we have identity spine graph at the core of all the features that we built. And that's how basically MIQ strives for a better connected marketing. I'll pass it on to Vikas now to take us through how MIQ built this identity spine and how we are using that.
Thanks, Neha, for setting up the right agenda. So what are digital identities? So digital identities refers to any piece of information that is basically referred or used to uniquely identify a user who is connected to internet. For example, it may happen that a person who is visiting to a store might have seen an ad on his mobile, and it may happen that he might have seen a McDonald's ad on his mobile app, and he should have visited a McDonald's store. So in this scenario, mobile ID device or the unique combination which is used to identify that particular user is his mobile ID. Similarly, it may happen that a person after visiting the McDonald's stores might come home and switch on his TV to start viewing something on HBO channel. So that TV might be connected to internet, and the TV might be having digital identities which may be referred to as the unique ID of the TV or the unique IP address of the TV. Similarly, it may happen that the person might be surfing any e-commerce websites using his mobile or using his laptop. So when he's using a mobile ID to surf any e-commerce website, then a mobile ID is generated. Similarly, if he's using his laptop to surf e-commerce website, then the website which he's using might be dropping a cookie in his laptop. So that particular piece of cookie will be referred to as a unique or a digital identity to identify that particular user. So the objective is that during these three scenarios, the person who is interacting with the internet is same, whereas to the external world, it may happen that he might be treated as three different users. So it's very imperative to link that particular piece of that particular person to all the different devices that he is using to get himself connected to the internet. So this is basically the aim of resolving the identities of a different user when he is connected to the internet using different devices. The idea of identity resolution is that to connect an individual who is viewing a mobile with the external world, so that the person is same when he's viewing his mobile versus when he's browsing the website using either via laptop or via his mobile ID. Similarly, the person can also be uh, viewing a TV or an HBO channel to surf any web series. So this identity resolution aims at presenting a holistic view of that user across any given channel or across any given devices. So how do we basically connect these digital identities in programmatic media buying? We take the help of identity resolution provider from our side, which is called Tapad. So Tapad has various pieces of information within its dataset. So one piece of information can be that a person who is visiting a website might have or might be assigned a unique IP address, as well as what Tapad does is that it uniquely associates a unique identification ID to that particular piece of information. Similarly, it may happen that a person might have seen an ad on his mobile ID. So what Tapad is that it also associates a unique device ID or a unique identification ID to that particular mobile ID. So what Tapad does essentially is that it associates a unique identification called as individual ID to each of these pieces of information, and then supplies all this information to our data lake. So our aim is that we would be connecting each of these pieces that is present in Tapad so that we are able to present a holistic view of a user when is connected online. For example, it may happen that a person who was viewing TV or and seeing a web series on HBO, what we can do is that, so what Tapad does is that Tapad assigns a unique identification called an individual ID to that piece of information called TV IDs. So now, since Tapad has assigned a unique identification ID, what we will do is that we will uniquely join that individual ID to the individual ID which is connected with the mobile devices. So by this way, what we can achieve is that we can have that person who was viewing TV and we can target him to show an ad when he's actually using his mobile ID to surf any web app. Similarly, this piece of information can be enriched by the piece of information when is connected to his laptop. So we can use the individual ID that was associated with mobile ID to join with the individual ID that was associated with the website ID or the cookie ID. So in this way, we are able to target that person who was viewing TV to show him an ad on his mobile, as well as to show him an ad when he is using his laptop to surf the internet. So this is the entire objective of the resolution that happens behind the scene. So what have we built? We have basically tried connecting different data sources from various data providers and have tried to come up with a holistic picture so that each of the individual IDs are basically representing cross-channel collaboration or the cross-channel linkages of the digital identities. For example, the identity that is linked with TV would be associated with the identity that is linked with mobile IDs. Similarly, the identity that is linked with mobile IDs would be associated with the identities that is linked with websites. So connecting disparate ID sources to strengthen the media product offering that we have, and also to be able to target a user across multiple channels, is the entire aim of this identity spine graph. So how have we done is that we have joined various multiple data sets that we are getting from various data providers. For example, in the left hand side of the diagram, we can see that we have location data that we received from a data provider called Factual. So this data has a digital identity called device ID. Similarly, the websites, or when a user interacts with a website, then a lot of data is generated. So those data are presented or given to us in the form of click data, or the clickstream data. So that is given by a DSP called the thread desk. This piece of data has information about cookies and the device IDs, which represents the digital identity of a user. Similarly, the bottom side of the diagram has data about TV, which we get from a data provider called Visio. So this Visio has basically information about the TV that we are having, and the TV IDs represent the digital identity here. So the aim is that to connect the digital identities from various data providers by using uh, Taped. So since Taped has information about the unique individual IDs associated with each of the devices, so if we connect all the different data providers with Taped, then the result of which, if it is gets connected again with Taped, then we can ideally, what we can achieve is that we can have a holistic view of a user across multiple devices and multiple channels. So the entire aim of this graph is to join the data sets from, or join these various data sets to derive a final identity graph. So the problem, so what are the problems that normally happen or that goes into while the join happens? So the data providers that we have are heterogeneous in nature. For example, location data is in TSV, whereas the TV data is CSV. Similarly, tape data is in JSON format, whereas the clickstream data or the website's data is sent to us in a Parquet format. So there is no uniformity of the data across these data providers. As a result of which, due to this lack of uniformity, it presents a hindrance at the time of joining. Also, the size of these data sets are very huge. For example, the data range, the size of the data ranges from 400 GB to around 600 GB across these data providers. What are the other challenges that we have? Due to this non-uniformity of data, the processing takes a toll, and processing takes around roughly high. Also, the data that we receive from these data providers, they'll end up in our data lake, as a result of which we need to make sure that the data that we are receiving is GDPR compliant. So GDPR states that we cannot store the digital information that we are receiving as part of these data providers in a raw format. So we need to be strategic enough here so that the data or the digital identities that we're storing from our side needs to be in a GDPR compliant way. Also, a lot of data that is sent to us is on a real-time basis. So the clickstream data or the websites data that a user interacts with is on a real time, as a result of which a lot of small files are generated from our side, and and the generation of these small files seriously affect the processing time of the pipelines. As a result of which, we have seen a very huge or very high infrastructure cost around the entire processing or this entire joining of these data formats. So the first step that we took in order to improve the processing is to enrich our data lake. So we converted each of the data that we are receiving to Parquet, and while converting, we introduced a logic of hashing all the digital identities. So the objective of hashing was that uh, we cannot store these digital identities in a raw format. We need to store the hashed format of these digital identities. As a result of which, we used MD5 hashing algorithm, and we converted all our digital identities from various data providers to hash digital identities, and then finally dump them into S3. After we have dumped our data providers into S3, we wrote various join operations on Spark, on Databricks, and as a result of which the entire processing took around roughly around 3 hours. We played around the partitions of Spark. We optimized the various partitions that were happening in the join operations, as well as we utilized the skew hints that was as part of Databricks. And as a result of which, we were able to join each of these data formats in a time of around 3 hours. But still, this was concerning because 3 hours was used as a join is considered, as far as join is considered, and because of which the time that went into this computation was mostly because of three factors. The first factor was that a lot of time was spent around counting the rows of the data frames, because we had to find that how many overlaps or how many pieces of informations are being joined with tapered data, the tapered data that we're receiving. Also, we need to be very strategic enough in order to have the runtime optimized from our side. So there was no runtime efficiency in this processing, as well as this processing is scheduled to happen every week, and every week the graph or the joint result of the joint needs to be refreshed with new incoming data. So this was a major hindrance, as a result of which we thought of optimizing it further. So what were the other pieces that we considered while optimizing? So the first piece was we migrated this entire pipeline to Spark 3.0 and utilized AQE feature, which is called as adaptive query execution. So as a result of which, AQE provides a lot of runtime optimizations in Spark when it comes to joining data sets, in terms of it dynamically coalesces the supple partitions at runtime, as well as it optimizes the join strategies. For example, if a join is taking longer time, then it automatically switches the join, a normal shuffle hash join, to broadcast join based on the data that is received into each of these individual stages, as well as it also optimizes the skew joins. So as a result of enabling this AQE feature, we had all our joins reduced, the processing time of the joins reduced to 1 hour. So this was a great optimization that we seen after enabling AQE on Databricks. The second operations that we thought was of migrating our entire pipeline to Delta. So since there were a lot of count operations that were happening in our pipeline, so Delta is a great way of having those processing involved, because Delta keeps a record of metadata of all the data that is stored internally, as a result of which any count that is done on the data frames is very optimized, and as a result of which the counts which were earlier taking around 10 minutes or around 8 minutes to perform have started showing a reduction of 50%, and now they started taking around roughly around 3 to 4 minutes per operation. The next optimization that we thought of doing was Z ordering. So Delta is a great method of optimizing your data sets when it comes to filtering and joining. There is another facility of Z ordering that comes on top of Delta, where what it does is mostly is that uh, it does a compact layout of your data set, so that all similar data files or all similar data are grouped into a single data file. As a result of which, when join happens, then at the runtime, a lot of irrelevant data is skipped. As a result of which, the processing gets faster. And this was evidently seen that when the processing was done on Z ordering, then the entire data or the entire processing reduced to 30 minutes, which earlier this process was taking around, like, let's say, around 40 minutes. The final piece of optimizations that we did was we needed our graph to be refreshed on a weekly basis on the same location. So without Delta, if we try to read and write into the same location, then there is a problem. We cannot read data and also write the data into the same location in overwrite mode in a normal Parquet way. So if we are using Delta, then because of Delta's ACID capabilities, we are able to write and read into the same location. So this enabled us to refresh our data into the same locations every time and have that location exposed to our internal reporting tool for further analysis. So what has been the impact of each of these? So the impact has been that the processing time has reduced significantly, around from the overall processing time of 3 minutes from overall processing time of 3 hours to 30 minutes. As well as there has been a lot of impact that was shown across cross-channel and cross-channel activations. So this increased the scale at which we are able to target users across different platforms, be it your mobile IDs or be it TV IDs. And overall, our infrastructure cost improved significantly. So there was a total of around 80% dip in the processing cost. So having this identity graph in place, we are able to achieve significant optimizations and significant result into our business. As a result of which we are able to target multiple people who are viewing TV and show them an ad on different media, as well as we are activating users who are offline or visiting a particular store, and then we are able to show them ad on out of home platforms. We are also able to preserve the digital identities of a user, and we are able to track the lifetime of it and accordingly utilize that piece of information for showing them ad. And this has resulted basically mostly around the how brands have been showing ads to their audiences, as well as there has been a significant upliftment of brand and their reach across their audiences. So this has been some of the highlights of optimizing these identity graphs and then using this identity graph in place. Thank you. So that's all from my side. And here's a link of our MIQ blog, internal blog, as well as a Medium blog, which we can utilize, which we have been posting regularly and refreshing regularly. So thank you.